Okay, this chapter is going to cover where'd it go? This chapter is going to cover the chapter 2 variables, expressions, and statements. And I'm just going to, I'll demonstrate each section or sections that I think are important in this, and then again I'll go through the exercises. Okay, so you should have your Anaconda open. You run your Jupyter notebook, and let's see here. I'm going to create a new Python file. I'm going to name it Chapter 2 Variables, Expressions, and Statements. Rename. Okay, so all right, so first thing, all variables in Python are objects, okay? And so what that means is if you're used to like C++ or Java, let me just show you this picture real quick. All your variables were called primitive data types, and you had to define your variables as a boolean, a char, a byte, short, int, long, float, double. So for like a whole number, an integer, your whole number, if you define an integer, could only be between this number and this one. So if you had like 100 trillion, that wouldn't fit in an int, and you'd have to put it in. You'd have to store that in a long, because 100 trillion would give you an overflow error. Okay, if you had like a negative 100 trillion, it would give you an underflow error. Okay, but Python is way different. Okay, all variables are considered objects, and so let me use my pen real quick here, sketch screen, so I can write on my screen. So like if I have x equals 10 and y equals, blah, what that looks like is you've got x pointing to an object that's got 10 stored in it, okay? And you've got y pointing to an object that's got the word blah stored in it, okay? Now, if I were to run, let's do this. We'll say y equals x here. No longer does y point to blah, it points to 10. Okay, and I'll demonstrate that real quick here. So if I have x equals 10 and y equals blah, and then I say y is now equal to 10, if I print x if I print y plus blank plus x, okay, that's not going to work because I need to do string concat. So if I make this a string, str, and I do str, okay, I'd have 10 and 10, okay? So they both point to the same object now, all right? So that's a little bit how objects work. It's not this isn't the proper area or time to go more into objects because we're only in chapter 2. That will come. But just know that all variables are objects and you do not have to define them, okay? So next up is variable names. There are illegal variable names that you cannot use. And I will show you those right here. So these words are called keywords right here. Python 3 has all these keywords. So you cannot use these words as variables, all right? Okay, let's see, raise. Okay, let's say you were creating a program to give yourself a raise for your pay, right? Um, which would make sense if you had like a variable pay equals, raise. Sorry, it would be like plus equals raise times 1.15. You want to give yourself a 15% raise, and then you want to print. Let's say we go in here and we say pay equals, 10 or whatever, right? So if we tried printing pay, we should get an error because raise is a keyword, so that's an illegal variable name, okay? Other illegal variable names, you can't start with a number, so like if I wanted to say for sale equals 10 or something, print for sale should give me an error, okay? Can't start with a number. And then there's like special characters that the book talks about. So if I had like, I don't know, email at 10 or whatever. Now you can have, sorry, I didn't do this. You could have sale for, okay? That would work, okay? I just want to demonstrate that. You just can't start with a number. So if I had email at XYZ equals, my email at hotmail.com, and this is the variable I wanted to use it. Print email at XYZ. If I wanted to print that and run that, I get an error, okay, because the at symbol is just a special symbol. What do they say in here? So the at symbol is just an illegal character that you're not allowed to use, okay? So that's that section. Other things I thought were important. So Java order of operations. So you use this thing called PEMDAS, which is parentheses, exponents, multiplication, division, addition, and subtraction. Okay, so if I were to do, I don't know, and this is stuff that you learn from elementary school. When you have a formula, you do everything in parentheses first, then you do exponents, then you do multiplication, division, addition, and subtraction. So if I did, I don't know what my variable is, total equals 1 divided by 2 plus 3. Let's see what that gives me. Okay. If I run it, should divide that out first to give me 0.5, then I add 3 to it. Now, if I were to do this first, okay, the parentheses, it's going to do the parentheses first. So that'd be 2/3. 1 divided by 2/3 is 0.2. Okay. So let's say you had, something like this. Which one would it do first? It would still do the first. It would do the division first, because you read from left to right. Okay. And again, this is something that you should know from elementary school, so you can remember as PEMDAS. It's just order of operations. Okay. Next up, you cannot. String concatenation is for strings. So, like if you tried to do this, print 2 minus 1. Okay. You're gonna get an error. All right. Okay, that's fine. okay, because you're concatenating two strings together. But it really should be used for something like this. If I wanted to say, and actually if you want to do, instead of printing that, let's say we had calculation equals that, okay. Okay, and I run this. Okay, it's still going to give me 21, but really what it's supposed to be used for, like name equals, or you could do print. My name's Mike Seeley, so I just put Mike plus Seeley. Okay, so you're really supposed to do it kind of like this. You get errors if you're trying to like subtract, or let's say you're multiplying that, okay, dividing that. It doesn't know how to deal with it because they're strings, right? And so you can't use your arithmetic operators on there, okay? But it doesn't mind the plus symbol, okay? The other one that it doesn't mind is, let's say I did, okay, that should print out my name 3 times, Mike, Mike, Mike. All right. So that's fine. So it doesn't mind the plus symbol and the multiplication symbol if it's used like this. Let me see. Okay, so the book talked about 3 types of errors. Okay, and I'm gonna do another sketch screen. Sketch pad. Let's do that. Let me delete that. So sketch pad. So 3 types of errors were syntax errors, which would be like something syntactically not correct. So if I had a string and I said, and I did not put that on there, okay, you're going to get an error because it's, you're supposed to start a quote and end a quote, okay? So that would give you a syntax error. There's runtime errors, okay? Runtime errors, your program will run until it hits the spot, and then it blows up on you with the compile error. So that would be like 5 divided by 0. You can't divide anything by 0, okay? And you can try that in your calculator too. Like if you've got one of those TI whatever calculators, this should pop up with an error, okay? And that's a runtime error. And the last one, they called it in the book semantic errors. And I've always known them as logic errors. And so in them, something logically is not calculating or not working correctly. Like your program runs, but it's spitting out the wrong answer. These type of errors are by far the hardest to find, because you don't get, when you run a program and it doesn't work because of a syntax error, runtime error, it blows up at a specific line of code, and then the compiler tells you what the problem is, okay? And even if you don't understand what the compiler is saying, you can look at the you can look at the line of code and start investigating what the problem is and testing it. With a semantic or a logic error, you don't know where that the problem is. So it could be something as simple as, let's say, you were supposed to add something and instead you put a subtract symbol in, okay? Now you got to go through your calculation and figure out, what the heck's going on. And that might be an easy example. There's, logic errors could take you a very long time to figure out where it's at. So it's good practice when you're coding. Don't just code your entire program and then check and see if it works. You should be testing each line or every other line of code to make sure that those lines of code work. And then you need to make sure that you're using proper test data. so that you can try breaking it. You should always assume that the end user is going to break your code. So you should be the one that tries to break it and make sure it's unbreakable by the time the customer or the end user gets the code. Because if a customer ends up breaking it while they're running it, that creates major problems. And you see this with like Windows. Every time they run an update, it's because there's bugs in their program, and end users are finding it, and the people at like Microsoft or whatever company have to go back and fix that kind of stuff, and it's costly, and it makes customers very unhappy. Okay, so those are the errors. And so now I'm just going to go through the different exercises here. So you guys can run exercise 1. I don't want to go through that. I mean, I'd rather go through exercises where I'm actually demonstrating like semi-program. So the first one, the volume of a sphere with a radius r is 4 divided by 3 pi r3. What is the volume of a sphere with radius 5? So first of all, you got to know what you're calculating. So you're trying to calculate the volume. And so you could say r is equal to 5 for your radius, and then you would say 4 divided by 3 times. Now there's a couple ways to do this. You could just say 3.14 for pi and estimate it, but a better way to do it would be to import math. And when you import math, you've got the ability to use all the different functions with math. So you could say math.pi, and that would give you the more specific 3.14, and then it goes up to like 10 different numbers in the decimal place. And then again, there's a couple ways to do this. So you could say times math.pow, okay? And pow is a function where you would pass in r, the radius, and then to the third power, okay? And if I were to print volume and run this, it gives me the answer, okay? Now, watch this. Bam, right there. That's called a comment, and so that's going to comment that out. If you don't want to do it like this, you could say r to the third, okay? Because in the book they don't teach you this math.pow yet, I don't believe. And so you could run this, and it gives you the same answer. So r, and this would be to the third power. So whatever way you want to do it is fine. I'm just demonstrating different ways and showing you that you can import stuff to be able to use their function. And so this kind of thing makes object-oriented programming super, super powerful. So I've never seen the pow function in Python. I don't know what it looks like, but I mean I could guess. It's probably it's probably got something like this in it, like x to the y power or whatever, and this would be assigned to x, and this would be assigned to y, and so it would return then that value. So that's what I guess would it look like, but I've never seen it, so I don't know. And what makes that powerful is that you can reuse this code over and over and over again once it's written, and you don't even need to know what the code even looks like. You just need to know how to use the function. It'd kind of be like driving a car. All of you know how to drive a car, but I'm guessing most of you don't know how to fix a transmission. But you don't need to know how to fix a transmission or how a transmission works in order to drive a car. And so that's what the power of object-oriented programming is they've created all these libraries of classes that have functions in them that you can use. They're already pre-built, and you just need to know how to call them. And so it might take you, it could take you years to learn all the different and become efficient at finding all the different functions in all the different libraries. But once you know how to do that, then you're really productive, and you're not having to rewrite the wheel every single time you need to use a function. Okay. So next up, suppose the cover price of a book is $24.95, but the bookstore gets a 40% discount. Shipping cost are $3 for the first copy and 75 cents for each additional copy. What is the total wholesale cost for 60 copies? Let me see here. Now, is it a 40% discount on the entire order, or is it a 40% discount on each book? I'm guessing it's 40% discount per book. Okay, so and that's how I'm just going to assume it. For some of this stuff, you could see what I just said. It's super important to be able to write proper English and be specific, because that's a question. Is it a 40% discount per book, or is it 40% for the whole entire order? I'm guessing it's per book, but programmers could get that mixed up. So, whoops. Okay, so down here we could say something like total cost is equal to, I don't know, 24.95 times, I think we order 60 books, times 0.6, because we got a 40% discount. And then you would say plus the first order is $3, I believe. For shipping, $3 for the first copy and 75 cents for each additional copy. So then it would be plus 0.75 times 59, because this is the cost of the first book, this is the cost of each additional book. So you could do print, stuff like total cost. Okay. One thing is, you want to be specific with your variables. Okay, the variable name, so total cost. I've had students complain that my variables are too long. They like using shorter variables, but it makes it easier for me to read. Okay. Let me think here. And the last one. If I leave my house at 6:52 a.m. and run 1 mile at an easy pace of 8:15 and 3 miles at a tempo of 7 minutes 12 seconds per mile and 1 mile at easy pace, so that's this. So you're basically running 2 miles at 8 minutes and 15 seconds. What time do I get home for breakfast? Okay, so I'm going to show you guys some stuff with modulus here too. So, okay, so I'm going to say my hours are equal to 6 and my minutes are equal to 52. That gives me my start time, 6:52, okay? And my run minutes are going to be equal to, the first one's 8 minutes. The next 3 miles are 7 minutes, okay? And then my run seconds are equal to 15 plus 12 plus 12 plus 12 plus 15. Okay. Now, let's run this real quick and say run seconds. Okay. Run seconds is 66 seconds, all right? 66 seconds is 1 minute and 6 seconds, okay? So my total amount of, if I did my run minutes plus equals, so if I added these up, I would get 21 plus 16 is 37. That's 37 minutes right there, okay? And then I got to add on the extra minute for all the seconds I've got for the 66 seconds. So in order to get that, I would say run seconds divided by 60. And I'm using 2 of these because I just want this to be converted to 1 second, and I want to dump the last 6 seconds. So I'm going to be off by 6 seconds on my calculation here. But that's all I care about because it just tells me what time I need to get home, and it's using hours and minutes. It's not using the seconds, okay? So if I do this then and I print this, I should have total minutes, which is basically 52 plus 38. 52 plus this plus the extra minute I got out of that, okay? Run minutes, and let's see what I get. That's right, okay? Sorry, wrong one. This should be total minutes running. Total minutes running. Sorry, I was looking at the wrong one. Okay, so that gives me my 38. Okay, so then if I do my minutes plus equals, now I'm doing combined operators here. It's taking my minutes, which is 52, and I'm adding my run minutes to them. Okay, and now I do a print, and I go my total minutes now. Sorry, this is what I was trying to do last time. It should be 52 plus 38. This should give me my 90 minutes here, I believe. Yep. Okay, 52 plus 38, so 50 plus 30 is 80, 2 plus 8 is 10, 80 plus 10 is 90. So that gives me 90 minutes here, okay? So 90 minutes needs to be converted to an hour and 30 minutes. So that would make that 7, and the minutes would be 30. So we've got some calculations to run here, all right? So my hours are going to be plus equals my minutes divided by 60, okay? And it's going to chop off the excess, okay? So 90 divided by 60 is just going to give me 1, okay? And so, and then I'm going to take that 1 and add it to 6, so I should get 7 right here. But let's test. Let's test and make sure I get this right. So I got print total hours, and it should be 6 plus 1. And let's see here. Total hours, that's my 7 hours, and now I need to still get my number of minutes left. So I can change minutes is equal to my minutes. Where am I at here? Is it my run minutes? Let me see, total minutes equals minutes modulus 90. So what this does is it takes the remainder now, okay? So let me do this real quick. Sketchpad. So if I've got 90 modulus 60, what I'm doing here is I'm taking 60 into 90, and this is old school elementary division, right, where you get a remainder. So how many times does 60 go into 90? It goes in once. 1 times 60 is 60, and so you subtract that out and you get 30. Okay, so the answer to this is 30, all right? Okay, so the rule for modulus, okay, if the left-hand side is greater than the right-hand side, then you run your calculation here, okay? But if I had 5 modulus 60, it would just return 5. So if the left-hand side is less than the right-hand side, return the left-hand side, okay? Does that make sense? So modulus is used in all sorts of things when you're using division problems and you want to figure out the remainder or whatever's left that you're working with, okay? So let's print this out, and so my total minutes Okay. Minutes. What did I do? Let's see here. I screwed up somewhere. So I've got minutes is okay. Minutes is oh, duh. Should be 60. Sorry, because 90 miles plus 90 would be 0. Okay, there we go. 30. I got worried there. I was like, come on now. All right, so this should give me, this is fine now. So that gives me 7 hours and 30. So it was 6:52, but when I ran all these hours or these minutes and seconds, it adds up to 7:30. All right, so now I just, do some displaying properly, and I could say time and just say plus str hours plus that should be fine. So the time is 7:30 at the end of this. Okay, so study that a little bit, and you guys can plug in the stuff that I plugged in. Part of programming is I'm making these videos to help you out and to give you an idea of where to start if you're kind of stuck on your projects that you got to work on this class. But part of this is you guys having to do this on your own and plugging and chugging and being frustrated. Watch this video and then go out and see if you can do it on your own, and use my work as a guide to help you. But programming is a tough subject that, it's not like the humanities where you can kind of just memorize everything. You really kind of have to, it's hands-on work, okay? So go ahead and practice this, and I'll post the next video, okay?